good girls like bad guys? I had this question for a real long time. I've been a bad boy and it's plain to see.
So when we were calculating the value for Z effective for the Fraunhofer region, for the various slits, this is the equation we used, and these were our diameters. These are the calculated values, and from our setup, because we were using a ruler, we could only get pretty much approximates for our Z effective.
Here we have the camera focused on the Fraunhofer region, and you can tell because we have the indicative Fraunhofer pattern as shown here. As we move the camera toward the source, you can see we're going into the Fresnel region. You can tell because we have two bright nodes up in here with medium intensity between them, which approaches the image of the source as you move even closer to the source. As we move away from the focus in the other direction, we stay in the Fraunhofer region. Here we see the diffraction pattern for the 20 micron slit, and the spacing between the peaks is very large for the small slit, and as we saw before, the spacing for the larger slit is smaller, so we know that the peak spacing decreases with increasing slit size.
So for the complex apertures, this is what we saw for the triangle, the circle, and the rectangle ones respectively. And this row is for the Fraunhofer region, this row is for the Fresnel region. So with the double slits, we could see interference within the main diffraction peaks, and what we noticed was that as the slit spacing was increased, there would be less spacing between the carrier peaks within these main diffraction peaks as shown here, and also as the slit width was increased, there would be less spacing between the envelope peaks.
Here's a simple graphical representation of the data we got for our circular aperture. We have our main peak normalized at 1, and we have our smaller peaks with their intensity shown here, and our noise value here, which is where this minimum is here. And to calculate the I1 ratio, we have to do C1 minus the noise divided by C0 minus the noise, and that'll give us our intensity value. And then we do the same process for the ratio of the C2 to the C0 peak, and we get errors for the circular 53.5% for the I1 to I0 and a 227% error for the I2 to I0. Okay, so for the rectangular slit, we perform the same procedure of subtracting out the noise and taking the ratio of the intensities, and we get this value and this value for the I1 and I2 ratios. And for our percent error, we got 16.9% for the I1 ratio and a 6.65% for the I2 ratio.